Hi students, Mr. Kaczynski with you. We've got 5.3 practice your skills solutions here, dealing with the substitution method of solving linear systems. Here we go. So we got the system of equations. It describes the distance traveled by two hikers, Edna and Maria, from the example in lesson 5.1. By setting the expressions of the right sides of the equations equal to each other, you can find the time when Edna and Maria meet. Explain what happens in steps 3 and 5. Okay, so you can see here that we got the original equation, this bottom one, 12 minus 2.5t. And in step 2, we substituted the 1.5 t for d. So right there. Okay. Next, what got done? Let's see. Looks like we're adding the 2.5t to both sides. So add 2.5t to both sides. All right, then this combined like terms, 1.5t plus 2.5t is 4t, and negative 2.5t plus 2.5t is 0. Then it just looks like we're taking that equation and dividing both sides by 4. So divide both sides by 4. And 4t divided by 4 is t, and 12 divided by 4 is 3. And that is the solution to that equation. All right. Check whether each point is an ordered pair to each system. If it's not, explain why not. Okay. We kind of did this in the last set of problems too, but good review for us. So we're supposed to just take that negative 2. Now let's start this over here. We'll take the 34, put it in for y. Take the negative 2 and put it in for x. And simplify. I think I'll use the calculator. So 38 plus 2 times negative 2 is 34. So we get 34 equals 34 there. Then we'll take the 34, put it into the second equation for y, and put the negative 2 into the second equation for x. And we'll see if that's a true statement. So negative 21 minus 0.5 times negative 2. And we get negative 20. So since 34 is not equal to negative 20, this is not a solution. So we'll say no, because it works in the first equation, but not in the second equation. It's got to work in both. All right. Let's speed things up here a little bit, and we got these decimals, so we'll just use all calculator here, I think. 32 minus 3 times that x value, 4.25. Oops. What did I do wrong? Oh. There we go. That gives us 19.25, and that's what we wanted to get, the 19.25. So let's do 15 plus 4.25, and that's going to give me 19.25 as well. So this is a yes, because the equation or the point works in both equations. All right, on to the third one, 2.3 plus 3.2 times, what's our x value this time? 2. And that gives us 8.7. Well, we wanted it to be 12.3, so this one doesn't even work in the first equation. So we'll say no, because the point does not satisfy the first equation. And with our first, oops, with our first 2a here was that the point didn't satisfy the second equation. All right, last one here, 3x minus 2y equals 10. So we're going to do 3 times x, which is 3, minus 2 times y, which is 0.5, and we want this to be equal to 10, but it's not. Okay, so we can instantly say no here because this point doesn't satisfy the first equation, and it really doesn't matter if it satisfies the second equation or not. So I guess I can just put the same reason here. All right, next up, solve each equation by symbolic manipulation. Okay, so let's start off. I'm going to add 3x to both sides. So 2x plus 3x is 5x. Then I'm going to subtract 14 from both sides. So 4 minus 14 is negative 10. And then I'm going to divide both sides by 5. And that gives me my solution of negative 2. All right, on this next one, let's start off by adding 2y to both sides. So that'll give me negative y plus 2y is y. And then I'm going to add 3 to both sides, and I get 10. On C, I think I'll subtract 2d from both sides. So 5d minus 2d is 3d. And then I'll divide both sides by 3. So d equals 3. And on D, probably the easiest thing to do is to start off by subtracting t from both sides and then dividing both sides by 3. Obviously, using the substitution method, you got to be pretty good at solving equations. All right, so we're going to solve these systems using the substitution method now. All right, so on each one of these, they're already solved for y, so essentially we're just taking the right side of the first equation and setting it equal to the right side of the second equation. Then we're going to solve this equation kind of like we solved these up here. So let's start off by subtracting 30x from both sides. And then subtracting 15 from both sides. And then dividing both sides by 2. And now we have our x value, but we need our y value. So how about we substitute that 5 into one of the equations. So we'll go y equals 25 plus 30 times 5. 25 plus 30 times 5 is 175. So our equation, or our solution to this system here, is 175. It does say check our solution. We're not going to check all of them. Well, I'm not going to. You should. But let's put this first equation in, 25 plus 30x. Let's put the second equation in, 15 plus 32x. And let's go to the table, go down to 5, and you can see the output at both of those is 175. All right, let's do it again here. All right, so the right side of the first equation set equal to the right side of the second equation. We're going to solve this equation. I think I'll add 5x to both sides and then subtract 20 from both sides. And then I'll divide both sides by 15 now. Not going to be very pretty, is it? 24 divided by 15 is 1.6. I guess we'll just leave it as a decimal. I mean, we could leave it as a fraction, which would be 8/5. Yeah, let's do that actually. Let's go with 8/5. Now we got to get the y value, so let's go y equals 20 plus 10 times 8/5. We can just put that into the calculator. 20 plus 10 times 8/5, or 1.6. Really doesn't matter what we put in there. And that's 36. So our solution here is 8/5 and 36. Maybe we check our answer algebraically here. We already know 20 plus 10 times 8/5 is 36. How about we put it in the second equation? We'll go 44 minus 5 times 8/6, or 8/5, which is 1.6. And that gives us 36 as well. So we're good there. All right, last one. 14 plus 7x equals 11 plus 4x. Let's subtract 4x from both sides. Then we'll subtract 14 from both sides, and then divide both sides by 3. We get our x value is -1. Then we'll plug that -1 into one of the equations. So 14 plus 7 times -1, which is just 14 minus 7, or 7. So it looks like our solution here is -1 for x and 7 for y. That's the point where those two lines would cross. Let's check it. I guess we'll check all three of our answers here. 14 plus 7x and 11 plus 4x. Let's graph it. And you can see at the point trace -1, 7 is where they both cross. A couple more to go here. Substitute 4 minus 3x for y, then rewrite the expression in terms of one variable. Okay, so 5x plus 2 times 4 minus 3x. We're just replacing the y with 4 minus 3x. All right, and then we'll simplify. So we'll distribute the 2, make it 8 minus 6x, and then we'll combine like terms. 5x minus 6x is -1x, or -x. So -x plus 8 would be the simplified expression. Let's do that again. Let's go 7x minus 2 times 4 minus 3x. We'll distribute. -2 times 4 is -8, and -2 times -3x is +6x. Combine like terms. 7x and 6x is 13x, so 13x minus 8. Okay, and full-fledged substitution method here on number 6. We're going to solve each of these systems by substitution. So I've got that y equals 4 minus 3x, so I'm going to substitute that into the second equation. So I'm going to do 5x plus 2 times 4 minus 3x equals -7. So that's the substitution part. Now I have to solve this equation. So 5x plus 8 minus 6x equals -7. That's -x plus 8 equals -7. And then subtract 8 from both sides gives us -x equals -15. So x equals +15. And then we have to substitute that 15 into one of the other equations. So let's go y equals 4 minus 3 times 15. That's the easier equation to plug it into. 4 minus 3 times 15. That gives us -41. So our solution here is x is 15, y is -41. That's the point where those two lines cross, or the only point that works in both equations. All right, on B, the first thing I'm going to do is change this equation to 4 minus 3x. Now isn't that what we just substituted in up here? 7x minus 2y. When we plug this 4 minus 3x in, we got 13x minus 8. So I guess we can skip some steps here and go with, we know when we substitute this in for y, we're going to get 13x minus 8. Okay, and that equals 18. And then I'll solve that. So I'm going to add 8 to both sides and then divide both sides by 13. And I get x equals 2. And when we plug that 2 in right here, 4 minus 6 is negative 2. So our solution here is 2, negative 2. We can check that real quick. Let's go 7 times 2 minus 2 times negative 2. And that should give us 18. It does. All right, 4 minus 3x. Okay, we haven't done this one yet. So we have to plug that in for y, but it's pretty simple because both of these equations are solved for y already. So we'll just go 4 minus 3x equals 2x minus 1. Let's add 3x to both sides. Add 1 to both sides. And divide both sides by 5. And then we just got to plug that 1 into one of our equations. So 4 minus 3 times 1, or 4 minus 3 times 1 is just 1. So our solution here is 1, 1. X is 1, y is 1. And again, we can check that very simply by plugging the equation into our calculator perhaps. Just one way to check it, both equations. We can go to the table, and you can see at 1, they both have outputs of 1. All right, one more. This one looks a little tougher here because I'm going to take this bottom equation and solve it for x. So I'm going to make it 1 minus 3y when I subtract 3y from both sides. And then I'm going to plug that 1 minus 3y into the other equation. So I'm going to do 2 times 1 minus 3y instead of x minus 2y equals 4. And I'm going to solve this equation. Distributive property gives me 2 minus 6y. Combine like terms, 2 minus 8y. Subtract 2 from both sides. And then divide both sides by negative 8. I get 3/4 or 0.75. And then I'm going to plug that 3/4 into this equation up here to get our x value, 1 minus 3 times 3/4. That's going to give me, let's see, negative 9/4 here. So let's make this 1 into 4/4, which is negative 5/4. Yes, you could have used a calculator to do that. You could have just done 1 minus 3 times 3/4. And then math, enter, enter, we'll turn it into a fraction, negative 5/4, just like I said. So we get our solution is negative 5/4 for x and 3/4 for y. All right, that's a long one, a lot of solving. Linear systems helps to be really good at solving equations to be able to solve linear systems through the substitution method. Have a good one.